Today we are going to see real-time clock, RTC. So RTC basically measures the passage of time to maintain a calendar and clock. So it will measure the time in terms of seconds, minutes and hours. In the LPC 2148, we are having ultra low power design to support battery powered system. It works on 3.3 volt battery. It provides, so what are the different parameters it will measure is it will measure seconds, minutes, hours, day of month, year, day of week and day of year. So naturally you will remember, now you will understand that for these parameters you are requiring different registers there. Okay, so these all registers are present there. One will be seconds, one will be minutes, hours, day of month, year, day of week and day of year. Okay, then it is having a dedicated 32 kilohertz oscillator or programmable prescaler from APP clock. It means it is having two options available there. Either you can have its own separate oscillator present there, or you can derive its clock from the internal clock of LPC 2148. So there are two options available for the clock. This is the first one and this is the second one. Okay. Similarly, power supply. Power supply can be given to the RTC either by battery. So this is a one way. You can use external battery or you can use internal or mains, that is a main supply of the LPC 2148. Common supply you can give there or you can provide separate battery. Now, what is the need of separate control or separate oscillator and separate battery? Because once you program the RTC, it can work independent of the LPC 2148. So, though you switch off the power supply for the LPC 2148, still RTC will continue to work, and therefore you are having the option of dedicated oscillator and dedicated power supply for the RTC. Okay. So RTC is a set of counters which measures time. It works when system power is on and optionally when it is off. It is clocked by either a separate 32.76, the same things are given here. Okay, so we'll skip this. We'll go to the next one. So the architecture here, you can see that this is the basic block which is generating the clock. So this is giving you the output in seconds. Okay, and its input is 32 kilohertz standard waveform. Exact frequency is 32.768 kilohertz. Okay, now there are two ways you can get it. Either you can have the oscillator, its own crystal oscillator is there. Here you can connect the crystal. Okay, so you can have crystal connected here which will decide its frequency. Okay, and the second one is you can have reference of clock divider which is taking the frequency from the LPC 2148 clock signal. Okay, so this is using the internal clock and this is generating the frequency. Either you can use this or you can go for the second one. That is given as the input to clock generator. Remember this frequency. This is the standard frequency for any RTC. One way it is described as it is 2 raised to 15 counter. Binary counter is going to generate this clock signal and it is given you round figure there. That means when its MSB is high, then the exactly 32.768 kilohertz is generated there. That is a one explanation of that frequency. And the second one is it's commonly used. So naturally you are having standard crystal present there which is used in all the clocks to generate 1 second time pulse. Okay, so when you give 32.768 kilohertz clock signal to any circuit, so if you use that crystal, you can generate exactly 1 second period. That is the reason this is used there and that is commonly available in the market. So that may be the reason this particular frequency is used. So time counters, it consisting of all those counters which we have discussed, second, minute, hours, days, day of month and all these things are present here. Okay, so this is one part of the RTC you are having. So this is generating the clock, or it is measuring the time. So this is the first thing. The second one is the alarm. You can set the alarm for the RTC. So for that you are having the alarm registers. So naturally what you will put in this, the alarm time. Whatever the time you want to turn on the alarm, that time is fed in these registers. So you can program it. So how the actually alarm will be generated? By using the comparator. So comparator will compare the contents of the alarm register and the time counters, and it will give the interrupt. Okay, and then you can generate interrupts for different things. So for that, interrupt generator is used there. Okay, so this is about the architecture of RTC. Now we will go to the different registers which are actually used there for RTC. First is the interrupt location register. We are not going into much detail of this register. Second is the CTC, clock tick counter register. Second is CCR, clock control register. These two are very important. CTC and CCR. CTC is clock tick counter and CCR is clock control register. Okay, then you are having some additional things are there. You can use this counter increment interrupt register. This is used in case of the interrupt you want to use in RTC. This is also used in case you want to use the interrupt in RTC. So I'm just giving you the list of the registers. This is the alarm mask register, and this is the group of total three registers there. 0, 1, 2 are consolidated time registers. So altogether, these three registers can give you all the parameters which are used in stored in different counters, like seconds, minutes, hours, days, week. All these things are together present in these three registers. I will give you the details afterwards. Okay, so you can use these registers also. They can be accessed fast. So consolidated time register 0, 1, 2 are there. Next, so these are the things which we have discussed about the RTC. This is a very important part of any RTC module. What you need is, you need seconds counter, minutes counter, hours, day of month, day of week, day of year, months. So when seconds counter is incremented, when it reaches 60, what will happen? It will increment minutes counter. Okay, it will increment this by 1. Then when these are completing 60, it will go to the hours. Okay, and when 24 hours are completed, it will change the day of the week and day of the month. These two are changed by 24 hours. After every 24 hours, it is going to increment these two things. Rather, day of the year is also incremented. So these three counters will be incremented after 24 hours are counted by the register. Okay, then months, after counting the days of the month, which will increment the month. Okay, and then the years. It is followed by the registers which are used for alarm. Alarm value in seconds, alarm value in minutes, alarm value for day of month, day of week, day of year. So all these, the same things which we are using for normal current time, this for the same way we are having the things available for the alarm also. Okay, so these are the so you can roughly say that you are having two registers which are related to the controlling of the RTC, that is CTC and CCR. Then bunch of registers to store all the values related to the time, like second, minutes, hours, and other things. Similarly, to store the alarm time, you are having a bunch of registers, group of registers present there. And then we are going to the last two registers, important registers rather you can say. Prescaler value. These are used to generate the clock frequency when you are using the internal clock of the LPC214. To generate the prescale value, you are using this. Okay. So, we will see the pre-internal and pre-fractional afterwards when we are going for the actual frequency calculation. Then the next one is clock tick counter register. In the clock tick counter register, you are having the bit number 1 to 14. Okay, so 1 to 14 means total uh, 14 bits are there. Uh, so it will count, it is 2 raised to 15. 2 raised to 15, that is 32768. That binary number, that decimal number is, this is equivalent to 2 raised to 15. Okay, so 2 raised to 15 means these bits are present in this clock tick counter. It will first, once it counts that many clock pulses, it will generate one pulse and that will be given to the seconds counter. So clock tick counter counts 32, the 32768 clock pulses, and it will 2 raised to 15 rather count the pulses, and that will be given to the seconds counter. So when it counts that many clock pulses, it will generate one clock pulse. So remember, the clock signal must have the same frequency. Okay, then only you will get 1 second time period. 32768 pulses are counted there. Okay, and every pulse is having the duration of 1 upon 32768, 32.76 kilohertz. Am I right? So when you give this calculation there, then only you are getting the time period of 1 second. Okay, so for that clock tick counter is used. So always remember the typical number 32768. This is the clock frequency for the RTC. By default, this frequency is used. Then the second one is clock control register. Bit number 0 is clock enable. When this bit is a 1, the time counters are enabled. When it is 0, they are disabled so that they may be initialized. So initially you have to disable it, initialize it, and then you have to enable it. The second one is bit number 1. It is CTC RST, that is clock tick counter reset. When the elements in the clock tick counter are reset, the element remains reset until CCR is CCR RS, that is CTC RST is changed to 0. Okay, so you have to make it 1 only initially to reset it, and after that you have to compulsorily keep it 0 so that clock tick counter will continuously increment. Okay, then the next one is CTT EST, that is test enable. These bits should always be 0 during the normal operation. Clock source, if this bit is 0, the clock tick counter, yeah, this is important, the clock tick counter takes its clock from the prescaler bit. If this bit is 1, the CTC takes its clock from, whether you are going to use internal clock or you are going to take it from the external clock. That is decided by this bit number 4 of CCR register. Okay, clock control register. If it is 0, internal clock. If it is 1, it is external clock. Okay. Now, clock frequency of LPC 2148. First we will see some facts about the LPC 2148, and then we will see how to take the internal clock signal for generating the clock signal for RTC. Okay, so we will see some terms related to the clock frequency of LPC 2148. So the first term is F oscillator. F oscillator is the oscillator frequency output. Okay, LPC 2148 is having internal oscillator. Here you can connect one crystal. Okay, so that crystal will generate one clock signal. Okay, and using this crystal, the oscillator is going to generate the frequency. Okay, this frequency is always called as F oscillator. Okay, F oscillator is nothing but the output of the frequency of the output of the oscillator, internal oscillator of LPC 2148. This frequency is passed through this internal PLL. Okay, when this signal is passed through this internal PLL, it is multiplied by some factor M. Okay, that factor is called as multiplier. So when F oscillator is multiplied by M, it will be converted into CCLK. Okay, what is CCLK? It is processor clock, or it is also called as system clock. It is used to give, this signal is given only to the system blocks of LPC 2148. Okay, it is not given to any other blocks. It is used only for the processor present inside the 2148. And then the third one is PCLK. PCLK is peripheral clock. To get the peripheral clock, PLL output is given to the VPB divider block. This VPB divider block will convert CCLK into PCLK. Okay, so remember the three terms: F oscillator, CCLK, and PCLK. F oscillator is oscillator frequency, oscillator output frequency. CCLK is the processor or system clock, and PCLK is peripheral clock. म्हणजे inside the LPC 2148 there are two parts. One is system and one is peripherals. For system you are having the PCCLK. For peripherals you are having PCLK. Okay. Have you understood this point? Okay. So next one is uh, the relation between these things. F oscillator, that is the crystal frequency. So the first equation is, if you want you can write down this equation. F oscillator into M is CCLK. Okay, and PCLK is nothing but CCLK divided by VPB DIV. Okay, M is the multiplier used in PLL0 to set processor clock. Okay, so it is multiplying the frequency, it is increasing the frequency. So always remember CCLK is greater than F oscillator. Okay, CCLK is greater than F oscillator, and PCLK is always less than F oscillator, or it will be equal to F oscillator. PCLK is less than CCLK. CCLK is processor clock and PCLK is peripheral clock. Okay, so always remember the three terms. I am going to ask you all these things. Okay, so be careful about the things related to the clock frequency of LPC 2148. Next, we are going for the calculation of RTC for the LPC 2148. Now here I am considering specific figures for the different calculations. Like crystal we are considering is the 10 megahertz crystal is connected there. Okay, so here the crystal frequency is 10 megahertz and the multiplying factor is 5. Okay, so CCLK is sorry, actually in register you are putting it as M, and when you are doing the calculations it will be M plus 1. So M plus 1 into F oscillator, so it will be 6 into 10 into 10 raised to 6. So we are getting it as 60 megahertz. Okay, then PCLK is, you can have different options there, like PCLK is equal to CCLK, PCLK is equal to CCLK by 2, PCLK is equal to CCLK by 4. These three options are available. Out of that we have selected by 4. So when you take CCLK divided by 4, it means we are generating the peripheral clock as 15 megahertz. Okay, so this is important. We have taken it as 15 megahertz. Now we are requiring the frequency for RTC is 32.768 kilohertz. Okay, here comes the prescaler integer and prescaler fractional part. So these are the equations for integer and fractional parts. Uh, Prescalar integer is equal to integer part of PCLK divided by FRTC. That is the RTC frequency. So PCLK is 15 megahertz. divided by 32.768 kilohertz minus 1. So it is coming out as 456. Okay. So prescaler integer is value is 456. Similarly, prescaler fractional, which will give you the exact 32.76 kilohertz. For that, we are calculating the fractional part also. So prescaler fractional is equal to PCLK minus prescalar integer plus 1 into 32768. These are standard equations there for calculation. Okay. So when you calculate it, you are getting the prescalar fractional part as 25024. So now we are starting with the program for the RTC. I have taken one standard program there from the kit which is available there. I'm just giving you the glance of what type of the delays are generated there. You can use one common delay also, not necessary to follow this, but this is just for your information. Different delays are given there. We have defined different pins there which will be interfaced there for initialization of the RTC. One is the reset, second is the enable, and the third one is RTC source. Okay, these three pins are in defined there. That means we have defined this names for this combinations of bits. Okay, then first delay is of 5 microseconds. So this function will generate 5 microsecond delay. This function will generate 200 microsecond delay. Next, 5 millisecond delay, 200 millisecond delay is generated there. 1 second delay. Different delays are there, and normal delay, one more delay is used. Okay. Then this is the LCD command or command write function that is used for LCD interfacing. Okay. So here uh, actually before going with this, what we are actually going to do is we are going to interface LCD with the LPC2148, and when you turn on the RTC, its output will be given to the LCD. Okay, so for that we have to initialize LCD, and we have to write the LCD unit. Here we have used 4-bit LCD. Okay, you remember that this is 4-bit LCD interfacing. Remember, LCD is having 8-bit only, but out of that we are using it in 4-bit mode. Okay, 4-bit mode means we are saving the 4 pins. Okay, instead of sending the data by 8-bit, we are sending it by using 4-bit only. So when you are using it by 4-bit, naturally the code will be more. You have to send the data twice. First you are sending the upper nibble, and second you are sending the lower nibble. Okay, means out of 8-bit. So if this is your 8-bit data, complete 8-bit data, you are dividing it in two parts. First you will send the upper 4 bits, and second you will send the lower 4 bits. Only that is a difference in this program with your original 8-bit LCD interfacing program. Okay, so this is lower nibble and this is upper nibble which you are sending there. Rest other things are same as that of your LCD interfacing. Only specific pins are used there for this is RS. Okay, this is bit number. What you can say 1 2 0 1 2 3 4 5 6 7 8 9 10 11 12 13. So RS is P0.13. Okay, then we are having the enable pin. So it is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So enable is P0.16. Okay, so this pin is P0.16 we have used there. That's all. So this is the modification from your previous LCD program. 2 times data is sent, one time upper nibble and second time lower nibble is sent. Rest all other things are same there, and P0.13 and P0.16 are used to send the data to the LCD control signals. Next one is the previous one was command, uh, command write. This is data write. Same thing. Only thing is the first one RS is equal to 1. Now this is the main program. Okay. Here we are setting the different pins, and then uh, we are going to initialize the LCD. So for initializing the LCD, we have given a different command. So I have told you that 38 is for 8-bit mode, 32 is for 4-bit mode. So this is used for 4-bit mode. Shift the cursor on the right hand side, then sets cursor move or display shift, then display on off, and this is display off, and the other one is the entry mode. Okay. Now this is the main code for the RTC. Now this is very important. I have told you that PCLK was peripheral clock. Peripheral clock is equal to processor clock divided by 4. How to set that? By making VPB is equal to 0, 0. This is the register which is related to the VPB divider. When you set this register to 0, it means your peripheral clock is equal to processor clock divided by 4. Okay, and then after that, this is integer. We have already done the calculations. Pre-scalar integer, pre-scalar factor, fractional value. We have loaded the integer part, fractional part. Then CCR, uh, RTC control register. So that here what we have done, reset signal is given and source signal is given. Means we have set it as the internal frequency from the LPC 214A, and we have resetted the clock tick counter. Okay, and now initially I'm setting some values in the registers. So what values we have set there? Seconds is equal to 59, minutes is equal to 59, hours is equal to 23, date of day of the month is 31, day of the year is 366, day of the week is equal to 0. Means when the one first count is there, it, it will immediately going to reset it. Okay, so 59 will become 1, 59 will become 0, because seconds after 59 it will go to the 0, 0. Minutes, once seconds are counted, it will again go to the, so initially it will become, make it all 0. Okay, so this will be 0 to 23, so it will become 0, this will also become 0. So initially all the registers will become 0 after this. Okay, next here CCR. CCR is ended with RTC complemented. Means here we have resetted it, and here we have removed the reset. Okay, so RST signal is made 0 here. Okay, RST signal is made 0, and then enable the counting. Start the counting. This is initialization of the RTC we have done here. Okay, so this is for the initialization of the RTC. I will repeat it. We have set the frequency appropriately for the, that is a peripheral clock we have set here first. Then we have set the clock frequency of LPC, your RTC here, that is the second. Third one, reset the clock tick counter and set the source as internal clock. Fourth one is initialize all the registers so that they will be initialized to 0, 0. Okay. Next one is fifth is remove the reset signal so that it will start the clock ticking, and sixth one is enable the counting. So these 6 steps we have taken in initialization of the RTC. Now the main program. In the main program, what we have done there, we have initialized the port pins where we are going to use the LCD. We have initialized the LCD. Okay, next we have done the LCD. We have just displayed one message to the LCD at the beginning. So it will just display the welcome there. Okay, and then we have cleared the LCD. So here LCD is clear, and after that we have initialized RTC. So now the RTC will start. Okay, once the RTC is initialized, now what is done? LCD command, it will again come back to the main position. Okay, and here what we have done is LCD underscore data is equal to R. Now what is R? R is the register of, here you have seen that these are the SFRs which are related to the RTC. So it will read the data from the R and it will divide it by 10 and it will send it to the LCD. Here it is mod 10. What do you mean by this? It is converting it into decimal value. Okay, hex to decimal. This is converting it into hex to decimal, and that number is displayed on LCD. Same thing is true for minutes and seconds. First it is converting it into hex to decimal, and then it is displaying it on the LCD. So it will first display the hour, then minutes, and then seconds. Now if you want, you can show other things also, like you can clear the display and you can say the day of the month, day of the year, like that. You can show like that, or but remember all this data is in numbers only. It will display the hex value only. For example, day of the week will be 0, 1, 2, 3, 4, 5, 6, like that. 0 will be Sunday, 1 will be Monday. So if you want to display Sunday, then you have to check whether that register is 0. Then you have to send the string Monday or string Sunday to the LCD. In that way, you have to write the code. Okay. So that is given there. Of course, it is going to increase the length of your code. But the logic is very simple. You can display anything there on your LCD. Okay, or if possible, select the display of 4 by uh, 16 by 4, that is 4 line display you can take, and you can display everything there. Okay, so this is the diagram where we have connected the LCD there. You can see here P0.13, this is P0.13 which is connected to the RS. Okay, so this is P0.13. Enable is connected to the P0.16. Okay, and upper 4 bits, this is very important, upper 4 bits are connected to the data bus 17, 18, 19, 20, where we are sending the, first we will separate the character and then we will send it to the LCD. Okay, so if I want to send 32 number, I will first send 3 and then I will send 2. Okay, so like that we are sending still 8-bit data only, but we will split it in two 4-bit numbers and we will send it to the LCD. Okay, so that way it is done. So this is all about the LCD RTC interfacing. Okay, this is the output of the RTC. You can this is a simple program where whenever you run this program, it will start counting seconds, minutes, and hours there. Remember, you have to set the property of this IC as 10 megahertz. Then only you will get the exact timing there. Okay. Mm. Now another question is how to initialize it. So for that we have to modify the code. So what modification we can do in the code is, here I am displaying it as for only date, hours, minutes and seconds. There you can use keypad interfacing through the keyboard, collect the numbers and put it in the registers, so that you can initialize or you can update hours, minutes and seconds according to the input from the keypad, and then according to that you can display the time. Okay, so that initialization part you can add there. if you want to start the RTC at a particular time, or you can give the flexibility to the user that they can start it. And once it is started, you don't have to run this code again. It will continuously go on displaying the things there. Okay. So this is all about the RTC. Thank you. Thank you, students.